Welcome to Yong Tuition. Let's continue our discussion about electricity. Today, I'm going to discuss perhaps the biggest misconception about electricity, namely, does electrical energy flow, or can we confidently work out the energy density of electrical magnetic field? Some of these ideas might sound a little bit shocking for some viewers, to be prepared and fasten your seat belt. And before that, if you haven't subscribed, please do so now. Okay, thank you. Let's go. The title of my video is Electrical Energy Flows, the biggest misconception about electricity. Well, we probably have taken for granted that electricity represents a kind of energy, and this energy, similar to the kinetic energy, and such as the water and air, must be travels or flow from the source to appliance. And in this recently, for example, the Science and Veritas published the video on the same topics, based on the same old idea that the energy can flow in the field. Interesting enough that I just dig out some of the Science early publication videos. He argues that the potential energy is not a real thing, tangible, but apparently he's also true believers of Poynting vector, which represent the energy flux. Interesting, isn't it? Now, let's just, before we go to this different scenario, let's just go to the explanation first. So we have, this is a simple diagram to show that if you connect the electric bulb with power supply, in this case, and we have the connection, the power supply is connected with electrical power line and eventually with a power plant. Okay. But doesn't matter how long the power transmission line is, we have to focus on why the electrical bulb is on. Okay. Perhaps we can use this cartoon to explain my idea. Now here, instead of talking about the lamp, I choose electrical heater instead, because it's easier to illustrate. So this rectangle represents the resistor of the heater. So once we connected these heaters with the power supply, then the voltage will form across the two terminals. As a result, the charged particle, in our case, is a negative charge. The electron will be accelerated. Okay. So that is the key. Why the electrical appliance can be turned on. These local electrons will, of course, collide with lattice atom in the metal, in the wire, or in a resistor, so that the thermal energy can be generated according to famous work energy theorem. Okay. So we don't have to consider, we don't have always use to focus on energy transformation from one to another. In this particular type of phenomena, then we can focus on how work is done in the first place. Obviously, the electrons are accelerated by the Coulomb force in this example, so that they will gain their kinetic energy. Secondly, the thermal energy is generated locally due to the electromagnetic condition, as I just mentioned. So in this diagram, you can see that this is a green circle represent the electrons in the wire, in the heater, so that if we use the AC supply, and they will oscillate locally. And so does the electron in a metal wire. Because the resistivity of wire is relatively small, therefore most of the heat will be generated inside this water kettle. So that is how the energy, thermal energy, is generated due to the work done by the local electrons. So during this process, we don't have to invoke the idea of the energy flow. As can we just go back to this idea? So both the science assignment and Veritasius argue that the energy must somehow flow from battery to electrical bulb. But my explanation is this: no electrical energy flow from the battery to the electrical bulb, but the work done by the local electrons. So this simple idea have, I believe, some profound implications. Let's discuss that. For example, we are always be told by our school teachers, and electricity is analog. Electrical current is analog, can be described by the energy of the water flow. So that we can see this diagram very frequently, that the power of electricity can be described by the water flow. But as I discussed in my other videos, this is not correct. Although some people argue that well, it makes sense for the beginners, for the kids. But this video is certainly not for the beginners, but for people who are really interested in physics. So that is why all of these analog, the descriptions, is wrong. Okay. Second, let's consider our conventional description about the power line. So what is the role of power line? I think many people would spontaneously answer, well, it is a transmission of electrical power. So what is power? Power is energy, the change in energy is the rate of energy change. So when you call it a power line, you actually suggest that the electrical energy can move, can flow along the electrical power line. But using this new idea I introduced, and this concept, this description is wrong. There's no energy flow from the power plant to the end users. Can I have a closer look of this diagram I prepared? So if you just use this cartoon like photons, perhaps many people would accept that the light bulb is on because electricity energy or electrical energy actually flow from power supply and to the bulb. Okay, but this is not the case. Okay, as I just mentioned. If I just continue our discussing of some of related misconception. One is electrical energy transportation in wire. Some of the news headline perhaps always uses these terminologies invented by themselves. Electrical energy transportation in the field, wrong. Electricity transportation, no, we cannot transport electricity. So a lot of big issues involved. Of course, what we do need to understand is that how the electrical potential is established once you switch on. Okay, so there must be some time taken for such establishment of the electrical potential across each electrical appliance. So that is an issue. Therefore, in line with this new explanation, the so-called power generation is not true. At the most, what we can say is electrical potential generator. So in each of the electricity generator, we create the electrical potential. We don't generate electrical power. So that is something necessary to understand. And of course, there are many other examples. Let's do it one by one. For example, perhaps you have heard that nowadays, because of the consensus of climate change, that many people believe that there are going to be an energy crisis if we are not allowed to use coal. So therefore, many researchers take this opportunity to advocate so-called wireless energy transfer. In particular, in this diagram, they argue that perhaps we can build some solar panels either on the spaceship, or actually build this solar farm on the moon. After that, we can use a proper transmission technology. In this case, presumably it's just microwave transmission, in order to harness energy from the remote energy source, which is a clean and green. Does that work? Oh, by the way, do you know where did they got this idea? That is a question. That's some historical question I would like to discuss today. Actually, this idea is nothing new, right? And to harvest the energy from the remote source. Do you know the name? Tesla, that's right. So actually, Tesla was the first person to introduce this idea that the electricity or electrical energy can be somehow transmitted without the electrical cable. And this picture was taken about 60 years ago. And one of the gentlemen in the picture is William Brown. And why this picture was taken, and why the energy transfer or transfers idea was be promoted among children. Okay, I'm surprised it's quite similar to what we our time. You see, if you look at the school textbooks and the many chapters in chemistry and physics are talking about how to harness energies, wireless. But this picture was taken when the Bill Brown built a powerful microwave emitter, and so that and the receiver of this is built on the other side of the hill or mountain. Actually, what they have observed that a fraction of the microwave energy can be harnessed by using what we call this rectangle. And of course, in my opinion, there's no energy flow from the emitter to the receivers, but the electromagnetic wave. Okay, so it is, in my opinion, it is what they observed in this experiment in 1964 is just the local electron in the antenna was accelerated by the electromagnetic wave. So that is why they can pick up certain amount of the electrical current remotely. So nothing surprise. And of course, the original idea of this wireless electricity transfer is proposed by Tesla. So in this famous tower, Tesla trying to persuade people that the electricity can be transmitted without build the electrical power lines. It sounds very attractive, but at the most, what Tesla could achieve is that he could light up a lamp a few hundred feet away. That's all. So, of course, recently you will see not of discussing popular science fictions that Tesla was considered as the hope of future, because he was the first person to advocate the idea that electricity can be transported from one location to another without build a wire. And of course, just go very quickly, this idea, probably more recent scenario would be the invention of these powerless chargers. So both for the mobile phone as well as for the car. So people believe that the energy can be somehow transported from the source wirelessly to the car battery. But actually, if you go to the detail, you will see that what they are doing is actually is based on Tesla's coil, in which the electrical field and also the magnetic field is oscillating. So therefore, it's just the electromagnetic conduction effect. For example, if you have used this electromagnetic induction stove, you know that this is nothing. It has nothing to do with energy transfer from the source to the heater. It is a local electron, which are accelerated by this, which is induced it is a local current induced by this oscillating field that is responsible for the heating. So there's another example. There are many examples, and for example, many researchers nowadays just spend a lot of time trying to get a research fund in order to investigate these issues. But I think to some extent it is nonsense, because based on this fact that if based on the fact that if this experiment done by the William Brown in 1964 is kind of the one step forward to realizing the powerless power supply why nothing important has happened over the past 60 years. Okay. Of course, in the future, and perhaps next time when you see this kind of diagram, it's not a little bit. Next time when you see this kind of diagram, perhaps you have to think twice. When they claim that power line plays a role as electrical power transmission superhighway, perhaps you have to ask what the material they are actually transported. Electric current, electrical energy, right? So that is this is some of the implication. We can go on for a long time, but today perhaps I just focus on the reasons. And I don't think I have enough time to discuss this. Perhaps today I just outline the ideas we're going to discuss in the future based on the response from the viewers like you. So certainly the origin of this biggest misconception about electricity worth further investigation. Actually, many claims in the textbooks and the popular video about electricity are actually speculations, such as energy in the electrical field, energy in the magnetic field, and energy in electromagnetic waves. Okay. The basic formula we can discuss is that the energy density derived from the capacitor and cylindrical inductor. And these two formulas, but I have to remind you that these two formulas for the energy density of electrical field is not accurate, because in this formula we haven't discussed the field outside this cylinder. Similarly, when we derived the energy density formula, we didn't consider the electrical field beyond the gap between the two plates. Okay. But interesting enough that these two formulas are consistent with Maxwell's equation. Okay. Actually, that is how Poynting proposed his Poynting theory, that he wrote the differential equation in the similar form, almost the same form as a differential equation for the fluid dynamics. So which that the energy density of electromagnetic field and the energy flux is derived mathematically. Okay. So actually, if you go to the history of the related discussing, you will notice that there is a heated debate on whether the energy can be carried by the electromagnetic wave. Okay, and that that discussing is in the context of classical field theory, and because in which the field, electromagnetic field, originally was treated as a mathematical notation, alternative mathematical notation of the charge property. So the field is always associated with charge, either static or the moving charge. So that is the origin of electromagnetic field. The question is this formula for the energy density of electrical field is correct? If you apply next time this formula to the electron, a free electron, you will find that this formula is strange. because you cannot get your result without assuming the radius of electron. In other words, if the if the radius of electron is too small, then you will get the divergence of the energy. Infinity, your result for the energy of electrical field energy of electron would be infinity. So we have to make some assumption. So in history, that assumption, this assumption has been made that the energy of the electrical field of electron, a free electron, must be comparable to the rest energy based on Einstein's special relativity. Of course, there's not much reasoning. You cannot explain this assumption. In this way, we can derive the radius of electron close to the 10 to power negative 15 meters. Okay. So sounds reasonable. But if you go to detail next time, we will see that if you accept this radius of electron, you will find that the electron is actually several times larger than protons. So the answer is that the formula for the energy density of electrical field is not reliable. How about a field theory? Okay. Because when we talk about the field, then we have to be careful. One is the field we just use as a mathematical description, as we did in classical physics, both gravitational field and in electrical field. Like we introduced this field as a mathematical notation of charge or mass distribution. However, in quantum field theory, and the field, by definition, must be treated as kind of the physical being. At least, they must possess the energy and the momentum. Although this is quite abstract ideas. If you zoom into some detail, so how did they derive these ideas in quantum field theory? Well, they have to pick up the mathematical formalism from the classical physics, in particular, the Lagrangian mechanics introduced in the 19th centuries or so, must be adopted because there's not many tools in the toolbox. And in a classical many-body system, and Lagrangian mechanics and also Hamiltonian mechanics are very helpful because that can be used to build the Lagrangians based on the kinetic energy and the potential energy of this many particle system. So Lagrangian is well defined in classical mechanics. By way of contrast, however, the Lagrangians in the quantum field theory is not well defined, in my opinion. From this expression, you can see that Lagrangian, although they argue that the Lagrangians in the quantum field theory still contain the so-called kinetic energy and potential energy, at least in the form of their mathematical expression. But if you go to the detail, you will find that what they are talking about is quite different from the idea of energy, well defined in classical physics. For example, the second term is called gradient energy. So if we consider curved space-time, and so that any derivative among the two coordinates can be considered as a source of this special energy called the gradient energy. And also, if you look at their definition of potential energy, which is quite different, should I say. For example, they never tell what this M mean. So this M squared, they never tell people what does this M mean, because they don't know what the M is. In the words of the Yong, this is a talk you can, next time we can discuss this video. He said, we choose the potential energy when we invent our new theory. So you can actually put any term to build, you can pick up any term to build your Lagrangians. Okay, let's forget about this mumbo jumbles. If you're interested, of course, I can go detail, but today I'm going to stop here. Okay, so basically, my preliminary study shown that the energy cannot be described by the fluid. Okay, therefore, energy does not flow. Okay, so it is the biggest misconception to believe that the electrical engine can fly from battery to the electrical appliance. Okay, I'm going to stop here, but please pick up like if you're interested in this video and make the comment, no matter how short the comment is. I will continue to discuss the basic issues about electricity. Thank you and goodbye.